Good evening, GCC College Algebra. Today, exciting, this lesson here, 13.3, geometric sequences. This is our last lesson. This is the last thing that we want to do in this class. And just like 13.2, which was more of an introduction to arithmetic sequences, this is going to be an introduction to geometric sequences. So if you did 13.2, and you kind of understand what's going on there with the difference between an explicit rule and a recursive rule, and what makes a sequence a special arithmetic sequence, this will be a lot easier. This will be a lot easier here. So a geometric sequence is a special sequence. It's a different type. So a geometric sequence is an ordered list of numbers Now, arithmetic had a common difference here that have a common ratio. And we use R for the common ratio. Now, in arithmetic, we had a common difference D. And the idea was that we could take any term, just add that common difference, and we would get the next term. Well, in geometric, we take any term and we multiply by this value R to get the next term. So let's look at some examples of geometric sequences. How about 3, 6, 12, 24, 48? Let's take a look at this. If I look at the differences, it goes up by 3, up by 6, up by 12. Not a common difference. This is not arithmetic. But does it have a common ratio? If I take 3 and multiply it by 2, I get 6. If I take 6 and multiply it by 2, I get 12. If I take 12 and multiply it by 2, I get 24. Take 24 and multiply it by 2, I get 48. This is geometric, and the ratio is 2. The common ratio is 2, multiplying by 2. How about if I had 1, 3, 9, 27, 81, ... What's the common ratio here? This is geometric. What's the common ratio? Now, sometimes finding the common ratio can be hard. So let me show you a trick. If you take any term and divide it by the previous term, for example, 81 divided by 27 is 3. 27 divided by 9 is 3. 9 divided by 3 is 3. 3 divided by 1 is 3. If I take any term and divide it by the previous one, that is my ratio. 48 divided by 24 is 2. 24 divided by 12, 2. 12 divided by 6, 2. 6 divided by 3, 2. All right, here's one for you to try. Suppose I have 100, 50, 25, 12.5, and so on. It is geometric. What is the common ratio? What do I multiply any number by to get the next number? Well, remember, I can use my trick. 50 divided by 100, 25 divided by 50, 12.5 over 25. They're all the same thing. Any term divided by the previous one. It's the same thing as 25 divided by 50. It's the same thing as 12.5 divided by 25. All of them reduced to 1/2. My common ratio is 1/2. Now, just like arithmetic, we have a special formula for finding the rules here. So the special formula, the general term is the first term times the ratio to the power of n minus 1. Instead of plus n minus 1 common differences, this is times r to the n minus 1, the ratio to the n minus 1. So this is my special formula, and this formula only works with geometric sequences. So this formula will help us to create formulas and help us to find terms. All right, so let's take a look. So suppose I have, and I'm going to look in my the exercise set here. I'm going to do a problem, so keep this formula in mind here. And let's take a look at problem number 28 in the exercise set. It says find the 8th term of 1, 3, 9, dot, dot, dot. We just saw this one. We know it's definitely geometric. I want to find the 8th term. Well, I could keep going, couldn't I? Multiply by 3, multiply by 3, multiply by 3 to get up to the 8th term. That would be one way of doing it. And that wouldn't be so bad because it's only the 8th term. What if this was the 18th term or the 80th term? Would you want to keep multiplying by 3s to get to the 80th term? No, no. So we're going to find a formula. We're going to use the formula a sub n equals a sub 1 times r to the n minus 1. So a sub n, let me use a different color for the work. A sub n equals a sub 1, the first term, which is 1, times the ratio. What's the ratio here? What am I multiplying any term by to get the next one? 3 to the n minus 1. So there's my formula. So if I want to find the 8th term, a sub 8 is going to be 1 times 3 to the 8 minus 1, which is 1 times 3 to the 7th. 3 to the 7th, oh gosh, that's getting to be a big number there. Let's use our calculator to help us out. 3 to the power of 7 is 2,187. So the 8th term is 2,187. Notice how we created a formula there first. All right, so very similar to arithmetic, but it's a different pattern and a different formula. Let's take a look at another question. Let's take a look at number 24. Now in 24 it says a sub 1 is 1 and r is negative 1/3. And it wants us to find a formula for this and then find the 5th term. Fifth term, I could also write that as a sub 5, right? That means 5th term. All right, so first thing I'm going to do is I'm going to create a formula. We know that we've got a sub n. The formula is a sub 1, the first term, times r to the n minus 1. So a sub n equals the first term, which is 1, times r, the ratio, which is negative 1/3, to the n minus 1. There's my formula. Now I want to find the 5th term. A sub 5 is the 5th term. 1 times negative 1/3 to the 5 minus 1. It's going to equal, let's see, this is going to be 1 times negative 1/3 to the 4th. Now it's an even power. Even though my ratio is negative, I'm taking it to an even power, so I know it's going to be positive. So let's see, open parentheses, negative 1 divided by 3 to the 4th power. I get that. I'm going to convert it back to a fraction by going to Math, Convert to a fraction, and it tells me that the 5th term is 1/81. Okay, so these are all nice, but these all have, what happens if it's not a 1 here? So I want to do an example now where the first term is not 1. So the example I'm going to use is number 22. And it says that a sub 1 is 6 and r is negative 2. All right, so the formula says a sub n equals a sub 1 times r to the n minus 1. Creating a formula for this geometric sequence, a sub n equals 6 times negative 2 to the n minus 1. Now here comes a very important thing. Be careful here. The 6 and the negative 2. We cannot multiply them. They cannot be simplified. I can't take 6 times negative 2 and get negative 12. Because 6 doesn't have a power, negative 2 does. This is not 6 times negative 2. This is 6 times negative 2 to some power. And we always have to do the exponents before we do multiplying. So you cannot simplify here. Okay, very common mistake. One of the most common mistakes in working with these geometrics is people think that they can simplify this. All right, so let's find a sub 5, which means the fifth term. A sub 5 equals 6 times negative 2 to the 5 minus 1. A sub 5 equals 6 times negative 2 to the fourth. I think I can do this in my head. Negative 2 times negative 2 is 4, times negative 2 is negative 8, times negative 2 is 16. 16 times 6. Let's see. I'm going to just do the whole thing on my calculator here. 6 times negative 2 to the power of 4, and I get that the fifth term is 96. So again, very similar to arithmetic. It's just a different format. It's a different form. Before we move away, let's take a look at one more sample problem. And for this one, I just want you to find the first 5 terms. So we're just going to generate this sequence given a formula. And the one that I want to use is, let's see, I assigned 11. I like number 11. We're going to do number 13. I didn't assign number 13. C of n equals 2 to the n minus 1 over 4. So that's my formula. And I want to find the first 5 terms. So C sub 1, my first term, is 2 to the 1 minus 1 over 4, which is 2 to the 0 over 4. 2 to the 0 is 1, so my first term is 1/4. C sub 2, my second term, is 2 to the 2 minus 1 over 4, which is 2 to the first over 4, 2 over 4, which is 1/2. There's my second term. My third term, C sub 3, is going to be 2 to the 3 minus 1 over 4. You see where I'm getting these numbers from? I'm taking this formula, and I'm just replacing the n with a 1, and then a 2, and then a 3. 2 squared over 4. 2 squared is 4 over 4, which is 1. There's my third term. My fourth term, C sub 4, is 2 to the 4 minus 1 over 4. 2 to the third over 4. 2 times 2 times 2 is 8 over 4, which is 2. And I've run out of paper, but I want to do one more term here. So C sub 5, my fifth term, 2 to the 5 minus 1 over 4. 2 to the fourth over 4. 2 times 2 times 2 times 2 is 16 over 4, which is 4. So there it is. So I have the first 5 terms. I've generated the sequence. If I take a closer look at it, and this one, strictly speaking, it is geometric. What's the ratio here? Well, what do I multiply any number to get the next number? What do you have to multiply by 1 to get 2? What do you multiply 2 by to get 4? Right? Or take it the other way around. 4 divided by 2 is a half. 2 divided by is 2. I'm sorry. 4 divided by 2 is 2. 2 divided by 1 is 2. 1 divided by a half is 2. A half divided by a quarter is 2. The ratio here is 2. And my first term is 1/4. The way it's written here is a little bit awkward. It might be a little bit easier if I wrote it like this: 1/4 of 2 to the n minus 1. That might make a little bit more sense. Now you can see, the first term is 1/4 and the ratio is 2. All right, ladies and gentlemen, that's it. Oh my goodness, we are done with the class, the last assignment. So this video lesson should get posted on Monday, May 4th, okay, because that's our last day. We should have another week to get all the assignments and the work done. So what I want you to do now is I want you to do the homework. 13.3. It starts on page 988. And I want you to do number 7, which is a fill in the blank. And then I want you to do 9 and 11 and 17, which are generating, writing the first 4 terms out. So you're going to just look at it, plug 1, 2, 3, and 4 in, and find the first terms there. And then I want you to do 19 and 21 and 25, which are finding a formula, and then using a formula to find the 5th term. And then one more, I want you to do number 27, which is going to give you an awkward geometric sequence. You're going to have to find a formula, it's going to be a little bit, it's going to be very similar to these, but the number's going to be a little bit more awkward here. So you're going to use the formula to find the formula, and then find a specific term. Like this, I think in number 27, it says to find the 7th term. And that's it. And as always, as soon as you've got this done, email the assignment to me. If you've got any questions, shoot me an email. Getting a lot of emails. Kind of falling a little bit behind, but I'll definitely make sure that everything's all caught up and everything's posted and you get credit for all the work that you're doing. So just keep them coming, keep working, keep it coming, and we'll make sure you get the grade that you've earned. All right, guys, so awesome. I will probably post another video a little bit later, kind of like a goodbye video, but this was the last lesson. And so the last lesson and the last homework, here it is. All right, guys, get to work. Good luck. Talk to you again soon. Bye.